Mastering the solid architecture principles is crucial for an iOS developer because it ensures the creation of maintainable, scalable, and robust applications. By understanding these principles, developers can write code that is easier to understand, test, and extend, ultimately leading to better app quality and faster development cycles. This video will go through each principle with step-by-step examples, making complex concepts clear and accessible. It will break down how to implement Solid in real-world scenarios, providing practical insights that can be directly applied to your projects. And if you want to escape tutorial hell, go ahead and ask a senior developer, myself. The link is down in the description. So today we are going to talk about the solid principles. What I have done over here is just created a simple demo project. Basically, you just need a file right over here. And we are going to have, for all of the 5 principles, we are going to have a bad example and a good example. So you can kind of assess what's wrong with the bad example, because at first sight, it might not look as bad. Then we are going to add in the good example so you can see how it should look like, how you should write code with the solid principles in mind. And of course, along the way, we are going to talk about why each of one of them are really important. But before we do that, what is solid? Well, solid is a list of principles, 5 to be exact, of course, and they are, as for single responsibility principle, open-close principle, Liskov substitution principle. Now, these last 3 are kind of intimidating, their names, but don't worry, we are going to get to the bottom of them, no worries. This will be on the next video, so make sure to subscribe to the channel and take a look at the link in the description for the whole playlist, so you can just jump to that second video in this series if you need to. And then there is the interface segregation principle and dependency inversion principle. Now today we are going to tackle the first 2, single responsibility principle and the open-close principle. And why is this really important? Why do you actually want to adopt these principles, the solid architecture? Well, that's because if you are trying, or at least trying, or you are doing a good job implementing Solid into your day-to-day programming, then your code will be scalable, will be maintainable, will be much more readable, and you will be able to work within a team much easier. Okay, so let's start off with the single responsibility principle. It states, a class should have only one reason to change. Now, basically this means that a class should have only one responsibility. It should have one feature. If you want to add more, then there's other stuff to do. But let's just have here a simple bad example, and then writing out a good example will make this even clearer. So let's say you have a class of user manager. And then, this manages the user, and then you would just write out a function called save user, and then, I don't know, just save to database or something like that. Save to database. There we go. And then you say, okay, this is the user manager, then we are saving a user, and then let's just say send a welcome email to the user. So a function send welcome email. Okay, and then send the email. Okay, at this stage, this might look really harmless, like we are talking about a user, and this is a user manager class, so it manages user stuff, saving the user, sending a welcome email. Now, why is this bad? Well, first of all, this is taking on too much responsibility. Yes, and then the first rule, single responsibility principle, means that you should take on a class or a struct, should take on one single responsibility. So how to manage all of this? Well, you would just have a different class for different responsibilities. As you can see, these are quite different responsibilities. Saving as user is very, very different than sending a user a welcome email. I know it's kind of counterintuitive because we are talking about the users, but still, it's about the responsibility. Here we have multiple responsibilities, saving and sending an email. Level up your SwiftUI skills with a personalized 1-hour Zoom mentorship session. Whether you're stuck on a specific challenge, need guidance on best practices, or want expert feedback on your code, this one-on-one session is tailored to your needs. Get clear, actionable advice from a senior iOS developer with 14 plus years of experience, and accelerate your growth with confidence. The link is in the description. So what would be the good example right over here for a better user management? Well, we would create separate classes for each of these responsibilities. Let's just take care of the first one, class, user, and because we are saving it to the database, we would call this persistence. And then we would just copy this out and paste it in there. Likewise, we would just have a separate class of welcome email sender. That's fine. Okay, and then let me just copy and paste it over here. Now we can see that each of these classes have only one single responsibility. User persistence is persisting the user, saving the user function, and then welcome email sender has only one functionality, one responsibility, sending the welcome email. Hopefully that's really straightforward now that we have the good example in place. Okay, let's move on to the second one from Solid, and that is open closed principle. Now let's take a look at what I have right over here. So software entities should be open for extension, you know, the open one, but closed for modification. Now, let's just talk a little bit about it. For example, a struct or class should be open for extension, but closed for modification, which means that you shouldn't modify an already created struct, let's say a person model or whatever. But if you want to add some extra functionality, again, you should not modify it. You should create an extension. You should extend it. And, with the Swift language, it's basically just using an extension. That's really, really straightforward to do. Now, let's see a bad example so we can take a look at all of this in code. And by the way, why is this really important? Well, first of all, using extensions, it's really your code will be really scalable. And you will see in just a second when we are going to get to the good example. Okay, bad example. Let's just have a discount. So we have a class, a discount, and then we are going to get the discount. So get discount, and then we are going to have certain types, and these are going to be strings. Of course, you may create here enums or whatever, but for now strings are fine. And then if type equals, let's just go with the silver gold analogy. So silver, then we are going to return 0.05. 0, there we go. Else, if type equals gold, then we are going to return 0.1, a larger discount. And otherwise, if none of the type is neither silver nor gold, then we're just going to return a discount of 0.0, so no discount. Okay, so this again might seem really nice. Like, okay, we have get discount, we just go through the silver and gold, and maybe you just have an enum, which is much more even confusing because then it kind of hides away the complexity and the problem over here. So this is not really scalable. Let's just say we just added another tier over here. I don't know, bronze. you would need to go right over here and then just change it. And you might say, okay, just adding one over here, it might not be a bad thing and it's not a good work. But maintaining such a code is really, really hard. Going into these functions and making sure that everything works, testing them out right, making sure that all of the other parts of the code work with your current change, it's really hard. So let's take a look at the good example. So right over here, what we need to do is separate the silver discount from the gold discount. So we are going to actually use protocols right over here. So protocols basically in a nutshell are kind of these contracts that we adhere to, and if we sign that contract, a class or a struct signs that contract, adheres to the protocol, it needs to implement its functionality. Basically that's it. Needs to adhere to that contract, so to say. So we are going to create a discount strategy protocol, which is basically applying a discount. And then, according to that protocol, we are going to create a silver discount, a gold discount, and then we are going to not just have class right over here. We are going to create an example with a checkout. So yeah, I know it's quite a lot. So let's just start coding. So first of all, the protocol, and this would be our discount strategy. There we go. And then get discount type. No, get the discount. Apply discount. Sorry, apply. So we just have a little bit of difference, and not type. Apply discount to amount and then double. Okay, we are going to get a double right over here. So this is our protocol. Great. So now let's take a look at the silver discount. Yeah, there we go. We just have some code to completion ready for us. Silver discount. And let me just see. Yes, actually, there we go. We have an apply discount to amount of double, and we are going to return 0.05. Let's take, I just clicked away. Let's just see if it's just going to go and have our gold discount. Let's just have a final class. There we go. Gold discount strategy. And then we are going to have to use the apply discount to amount, and we are going to return 0.1. Let me just copy that out. Okay. So multiplied, amount multiplied by, there we go. Okay, so now that we have all of these discounts right now, not just one big discount, we can just use it. So let's create a checkout. Let's have class of checkout, and then our func of total, let's just see, let me just start this out because I want a base price would be our double, and then the discount, which is going to be a discount strategy, and we are going to have a double being returned. Now, please note over here that we are actually making this really flexible. We're not saying that this should be a discount like over here with the bad example. We are going to provide this total base with the base price function, a discount strategy. And you could just create a bronze discount, another discount, whatever. So this is really, really scalable. So now what we have to do is just going to have a discount dot and then apply discount to the base price. And as you can see, it's really straightforward, really easy to write all of these functions out. And basically that's it. This is how easy it is to make your code a little bit scalable and fragmented, so you can just add or remove stuff at will with ease from your code. And that is the open close principle. Open for extension, but closed for modification. Now, the third, fourth, and fifth principle will be covered in the next video. Till then, if you like these types of tutorials, also go ahead and check out my mentoring sessions. The link is down in the description.